Hi, everybody. Welcome back to 1342. Let's look at one type of chapter 4, section 1 homework assignments. All right, number 1. If A denotes some event, what does A bar denote? If probability of A is 0.008, what is the value of the probability of not A? Not A denotes, event A denotes the complement of event A, meaning that A consists of all outcomes in which A does not occur. Yep. Nope. It means that A and A share, no, they don't share any. Nope. So it's A. Because the probability of A plus the probability of not A is 100%. So in other words, with that, so if probability of A is 0.008, the probability of not A, let's subtract 0.008 from both sides. So 1.000 minus 0.008. So it's going to be 9. So it's going to be 0.992. Basically, it's whatever's in A, take it away from 1. Right? Which of the following cannot be probabilities? Remember, probabilities have a couple of conditions. Each probability has to be between 0 and 1, and the summation of all probabilities has to equal 1, and they have to be equally likely to happen. So 1.43, that's bigger than 1. That cannot be possible. That cannot be possible. 3/5 is 0.6. That can happen. 5/3, nope, that can't happen. It can be 0. It can be 1. 0.04, it's okay. Can't be negative because it can't be less than 0. You can't have an irrational number. Can't be a square root. So those 4. Is it possible to get 10 kings when selecting cards from a shuffle deck? Express selecting cards. The probability, if you did it 10 times, it would be so low. It'd be very, 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 very small. It all depends on how many times you take it. Selecting cards from a deck. So no, it can't be done because you only have 4 in a deck to begin with. Okay. Number 4. Let's see this one. Refer to the sample data for pre-employment drug screening shown below. If one of the subjects is randomly selected, what is the probability that the test results are false positive? Who would suffer? Probability of false positive. Okay, so we're looking at how many tests do we have in total? It's 48 plus 43. Is 91. So N equals 91. A false positive is somebody who's not a drug user tests positive. So it would be 2/91, which is how many decimal places? 3 decimal places, 0.022. Who would suffer? The employer. They'd get sued. The person tested would suffer because he or she would be suspended for drugs. Yeah, that's true, not the employer. The person tested would suffer because he or she would not be suspended. Would not be suspended? No, it's B. Number 5. There. All right. In the genetics experiments on peas, one sample's offspring contains 393 green and 447 yellow peas. Based on these results, estimate the probability of getting an offspring that is green. Is that result reasonably close to 3/4? So 3/4 equals 0.75. No, because, well, let's see. If we add these together, how many do we get? 840. So we want the probability of getting a green. So that's 393 divided by 840, which is equal to 4678. Three or 4.75. No, it's not reasonably close at all. Because this one's 0.46, this is 0.75. You're a third of the way out, which is 33%, which is bigger than 5%. Sample space listing the 8 simple events that are possible when a couple has 3 children. Boy, 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 girl, so forth. After identifying a sample space having 4 children, list the probability of getting 2 girls and 2 boys. Okay. So this is our sample space here. We have 4 boy, boy, boy. We have boy, boy, girl. Boy, boy, girl, boy. Boy, girl, boy, boy. Girl, boy, boy. Then we have boy, boy, girl, girl. Boy, girl, boy, girl. Boy, girl, girl, boy. Girl, boy, boy, girl. Girl, boy, girl, boy. Girl, girl, boy, boy. Boy, boy, no, boy, girl, girl, girl. Girl, boy, girl, girl. Girl, girl, boy, girl. Girl, 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 boy. And all 4 girls. 6, 7, 8, 9, 10, 11, 16. Try this. That looks good. There should be all possibilities. So we have 16 of them. Identify sample space. There you go. Identify a probability of getting 2 girls and 2 boys. So how many possibilities are there? There's 1, 2, 3, 5, 6. So it's 6 out of 16. So your probability is 375. 37.5% chance. Yeah, the hardest part is coming out with a sample space. See what you need, what you have, what you don't need. Using the given probability value, determine whether the sample results could easily occur by chance, then form a conclusion. The study addresses the issue of whether pregnant women can correctly predict the gender of their baby. Among 104 pregnant women, 57 of them correctly predicted their gender. So we have 57 over 104. Get this back on. What is that probability? 57 divided by 104 is 0.5480. If a pregnant had no such ability, there is a 0.327 probability of getting such sample by results by chance. Yeah, so it's, let's see, 3%, 3 point. Yeah. So let's see this. The probability shows that the sample result could have easily occurred by chance. Yeah, it could have. It appears that there is not enough evidence to support a conclusion that you can predict. Because you're looking at 50, pretty close to 50% chance. So somebody without the ability had a 1/3% chance. Okay, let's see this. Modify it. Now we're going to gambling. A modified roulette wheel of 36 slots, 1, 0, and these are both green, and a double 0. Occur in other numbers of 1 through 34. So 1 through 34, half are red, half are black. So it's 17 of each, and then a 0 and a double 0. What is the probability of winning? Probability of winning is, well, if you bet on a 0, it's 1 out of 36 on both of those. Or you have a 17 out of 36 chance of winning if you go with black or red. What are the odds against winning? So against winning, it's now in a, so this is the chance of losing, this is the chance of winning. So there's 17 chances of winning. That means there has to be 19 chances of losing. When you bet that the outcome is an odd number, the payoff is 1-to-1, meaning for every $1 you bet, you get $1. If you place a bet of $17, you would win $17. How much profit should you make on the $17 bet if you could somehow convince the casino to change the payoff odds so that they are the same as the actual betting fees that we looked at? So if you lose, you lose $17. If you win, you'd get 19. Round your nearest cent, so 0, 0. Fill in the blanks below. The blank for procedure consists of all possible simple events or all outcomes that cannot be broken down any further. That's the sample space. Because sample space are all possible outcomes. The classical approach probability requires the outcomes are not rare, equally likely. All right, that's it for that one. Good luck, everybody.